Okay.
Hey, Ted.
Never say I didn't try. That's right.
Ted Pyatt, let's see.
Tyler, we miss you.
If you're listening, but you're not.
If you're listening, but you're not. Bailey might listen. She was absent.
Bailey's been gone.
She might. Okay.
Yeah.
Bailey, we miss you too. All right. So, remember, when you're looking at these identities, you want to think about the formula sheet. What does this look like? So we should notice something in here that looks like something on my formula sheet. What's standing out to us?
The highlight?
What in our problem looks like something that's on our formula sheet? Maybe one of these, perhaps.
The first one.
The first one.
Oh.
Kind of looks like that. Okay? So we want to get there. Keep that in mind. You want to use context clues from the problem with your formula sheet. So I'm probably going to want to leave this alone and leave this alone, but I do want to simplify this part. A couple ways you can do it. You can either change tangent to be sine over cosine, or you could change tangent to be 1 over cotangent. That might be nice because you already have a cotangent and then they're going to cancel. It doesn't matter which way you do it, you'll get the same answer. So let's,
they cancel?
you need to show it. So tangent theta, oh, I said I'm changing it to 1 over cotangent. You could leave it that way. So I'm going to change tangent to be 1 over cotangent. This is understood multiplication if there's no symbol. Leave cotangent as it is, but put it over 1. Everything else is staying as is because it's r squared. And then we can see our cotangents are going to divide out, leaving us with just 1 over 1, which is 1. Okay, now you either need to get it to look exactly like this using inverse operations, or some of you will have on your formula sheet that sine squared equals 1 minus cosine squared theta, like when we did all the adaptations. If you do that, you can say sine squared equals sine squared. You have to write it though. Or if you don't have all of those written on, you can use inverse operations to add cosine squared to both sides. The inverse of subtracting is adding. And then you'll get the exact identity. Backwards, but we know the symmetric property allows us to flip it. And then we can put 1 equals 1. We want the exact same thing on both sides. All right, B is where we're going to really get into it. Okay, sorry. Just warning everyone. Everyone should pay attention on this problem. It's the hardest one on the sheet.
So the test question.
Yes. All right.
It's the first straightforward answer I've ever got.
The first thing we're going to do, just like if you saw in algebra, something outside of our set of parentheses, what property do you use to
Distributive
Oh,
property. Yeah.
just gave it away.
Yeah, let's go.
That's right.
Distributive property.
Distributive property of multiplication. It's actually just distributive property, but it's okay. So we'll have cosine theta times tangent theta. And if you want, you can leave off the theta if it's bothering you. I don't really care if you don't want to put the theta. I'm okay with it. And then cosine theta times cotangent theta equals cosecant theta. So all I've done is I've distributed a cosine. All right, now, since we don't have any squared terms, we're not going to be using our Pythagorean identities, unfortunately, because those ones are usually the easier ones. So I suggest that we change all to sine and cosine. So anything that's not a sine and a cosine, change it, using your formula sheet, into sines and cosines. So the cosine, I would leave it as cosine, but I'd put it over a 1. The tangent, what would I change the tangent to be from my formula?
Sine over cosine.
Good, sine over cosine. Bring down your plus sign. Okay, cosine again is going to stay as cosine. Cotangent, what am I going to change that to be? Cosine over sine from my formula sheet. And then it's up to you whether you want to go ahead and change this also. Most students, I think, like to. So if you want, go ahead and change this to be 1 over sine. You can leave it cosecant and then just prove cosecant equals cosecant at the end, but a lot of students like to change it now. All right. Now, let's start canceling stuff out, but remember, you can only cancel out if it's multiplication and division, because those are inverse operations. Can I cancel anything out in the second set? No. All right, so I'm left with sine theta over 1 plus, what's cosine times cosine? Cosine squared over sine equals 1 over sine. Sines can't cancel. I know, we want them to. But if they did, actually we don't. You get cosine squared equals 1 over sine, which is not true. So hopefully you'd realize you got it wrong if you cancel this. But the inverse of adding is not dividing. That's why they can't cancel. Okay. Now, to add fractions, what do we need to do? We need a common denominator. Common denominator is going to be sine. So I'm going to multiply the top and the bottom by the sine function. So sine times sine is sine squared. And we should notice something. Hopefully, possibly. What is sine squared plus cosine squared? Equals 1. So what I was saying yesterday about if you have two separate fractions and they have the same denominator, you can write them as one fraction. You don't have to necessarily do this. You could just skip this step, but for your notes, I like to have it. So all I did was I took the two fractions that have a common denominator, wrote them as one big fraction. And then we know that sine squared plus cosine squared equals 1. So this whole thing is 1. So the final answer is 1 over sine equals 1 over sine.
Which is so many steps.
Wow. Why does it have to be so many steps?
This is the longest one that you have.
Yeah, I knew they were going to be long when I saw that there was 2 on this huge page.
The ones on the back have a lot of space too, but there's not a lot of work with them. Not as much work. Okay, you will see one like this in your homework. It's almost the same problem, but I think it says sine out front instead of cosine. But it's going to be the same process. So make sure you're showing work. Attention, gentlemen. Some of you have been doing your homework on the sheet of paper. This problem would not fit in the margin. Okay, you need notebook paper or white paper or the back of the sheet, somewhere that you can display your work if you'd like to receive credit. Okay, should say ladies as well, but it's mostly the gentlemen of the class that were squeezing answers on the margins. Okay. Now, on the back, one thing you do want to keep in mind is you want to look for what I call shortcuts. Okay, shortcuts are when you see a complicated expression like this, yes, we can distribute, right? We can. But before you distribute, look at your formula sheet and say, do I know what 1 plus cotangent squared is?
Yeah.
Oh, I do.
Yeah.
It's cosecant squared. So if you notice a shortcut, you can actually get rid of, instead of distributing, if you distribute it will still work, you'll get the same answer, but it can shorten your workload. This is the cosecant squared. Again, all I did was I used that formula. Okay? Now, all of these formulas that we have as trig identities, these work as squares as well. So if you see sine theta equals 1 over cosecant, that means that sine squared equals 1 over cosecant squared. So it's up to you whether you want to change this to be 1 over cosecant squared or you want to change this to be 1 over sine squared, but they're going to end up canceling out. So let's go ahead and change this one since I have that formula highlighted. This would be 1 over cosecant squared times, you don't want to change both things. You want to try to change only one, leave the other one, that way you have canceling going on. But I will put that over a 1. And then we should see that these indeed divide out to get me 1 equals 1. Any of you that may have been on Google Classroom looking at my notes, I don't think I did that way on my notes. I actually distributed it. It works, it's just longer. Alright, the last one is actually kind of a review from yesterday. So you can see that this one looks almost identical to this one on our formula sheet. 1 plus tangent squared equals secant squared. The only difference is that we have this negative. Okay? Again, yesterday I told you, if you're squaring the negative, it ends up becoming a positive. Make sure you understand why, though. So you'd be using this formula that's off my board that says tangent of a negative angle equals negative tangent of a positive angle. So you take that negative, you pull it out front, it becomes like a negative 1 times tangent theta. You want to think of it like that. You still have to square that whole thing though. And so whenever we do square the negative 1 and we square the tangent, you end up getting positive 1. So it's just and since tangent squared plus 1 equals the secant squared, I can say that secant squared equals secant squared. Alright, I'd like you to complete the 2 closures and we'll get 2 of you to the board. Your homework is only 4 problems, 24, 25, 26, and 31 from that same page on notebook, paper, please.
I'll do the closures.
Por favor. Just in case anyone's watching, they can see the closures. Morgan was not kind enough to put them up.